All right, welcome to our next video in our circles unit. And today we'll be finding arc measures in circles. Let's go ahead and get started with some vocabulary. So if you want to take a second, pause the video, write down the vocabulary words. Our first vocab word is central angle, and that is an angle with its vertex at the center of the circle. So in this circle down here, the center of the circle is B. B is the vertex of angle ABC. So therefore, angle ABC is what we call a central angle. Now we also have arcs, and arcs are basically portions of the circle. So that'd be like from A to C on the circle. Arcs can be put into one of three categories, similar to angles. We've got a minor arc is going to be an arc that has a measure of less than 180 degrees. We have a major arc, which has a measure that's more than 180 degrees. And then a semicircle is going to be an arc that has exactly 180 degrees. So similar to acute, obtuse, and right angles in a triangle. So less than 180 is called a minor arc, more than 180 is called a major arc, and then exactly 180 is called a semicircle. All right, so the measure of a minor arc is going to be the measure of its central angle. So in this case that I have over here, I've got a measure of angle ACB is given to me as 50 degrees. So that's the measure of angle ACB right here. Okay, that's also going to be the measure of of arc AB. So we'd say this right here is the measure of arc AB. We say arc AB by putting a little arc over the top of it. And the measure of arc AB in this case would be 50 degrees. All right, the measure of the entire circle, we should know this, is 360 degrees. The measure of the major arc is going to be the difference between 360 degrees and the measure of the related arc. So for example, arc AB over here is given to us as 50 degrees. And if I want to talk about the major arc, so I would call the major arc would be from A through D and then to B. So we call that major arc ADB because it starts at A, goes through D, and finishes at B. And the measure of that would be the difference of 360 and that arc AB, which is 50. So 360 minus 50 would be 310 degrees would be the measure of that major arc. If I add the major and minor arc together, it should equal 360, which 50 and 310 does. Also, if we have a semicircle that's exactly half of the circle, so it's going to be half of 360, which is going to be 180 degrees. All right, next up we have the arc addition postulate, which says that the measure of an arc formed by two adjacent arcs is the sum of the measure of these two arcs. So again, what this is saying, if I have one arc, AB, and then a second arc, AC, to find the measure of arc CAB, I would have to add up the two arcs that I have. The measure of arc CA plus the measure of arc AB. So all we do is take the two parts, add them together, and that gives me the entire arc. All right, this pie graph on the right represents the different ways that you're going to save money at your due bank. And we're given the central angle measures of every single one of these sections of the pie. So each one of those degrees is given you as the central angle. Now we want to find the measure of arc BD. That's the first thing that I want to find. Okay, so BD, and we always assume the minor arc. I can go from here to here, or I could go from here to here. Now anytime you just see two letters, we want to assume the minor arc. So only one of those two arcs is going to be less than 180 degrees, and it's going to be the first one, the red one, that will be less than 180 degrees. So to find this, we need to find that there's two parts. We have arc AB, which is going to be from A to B, and we have arc AD, which is right here. Now each of these arcs is equal to the measure of the central angle. So AB is going to be 55 degrees. AD is going to be 105 degrees. So to find the measure of arc BD, we need to add 55 and 105, and now we get 160 degrees for the measure of arc BD. Now for B here, it asks for the measure of arc BCD. Now we don't have a choice with this. We don't have to assume a minor arc. When I'm given 2 letters, we have to assume the minor arc. But if I'm given 3 letters, we basically just follow directions. Start at B, go through C, and finish at D. And again, we're going to use the same strategy with this. We know that arc BC right here is 140 degrees. We know that the arc DC right here is going to be 60 degrees. And again, I'm going to add them together. 140 and 60 is going to equal 200 degrees. So that's the measure of arc BCD. Now, because these two are a minor arc and a corresponding major arc, we should be able to add them up and equal 360. And if I take 200 and 160 and add them, it does equal 360. All right, 2 more quick vocab words. So you can go ahead and pause it and write these down again. First one is congruent circles. 2 circles are congruent if they have congruent radii. Really, a radius is the only measure that a circle has. So as long as 2 circles have a congruent radius, then they would be congruent to each other. In order for arcs to be congruent, not only do they have to have the exact same measure, but they also need to be on congruent circles. So we want to find out whether or not these arcs that are given are congruent to each other. So I'm looking at FG and HJ here. Now both of these have central angles of 90 degrees. So in order for arcs to be congruent, we need to have the exact same measure. FG has a measure of 90 degrees, and HJ has a measure of 90 degrees. So one of my 2 criteria is met. They have the exact same measure. The second thing needs to be true is that they need to be on the same circle or on congruent circles. Since we see that they have a congruent radius, so this one right here, and that's a radius right there, those are marked as congruent, we can go ahead and say these circles are congruent to each other. So because they have the same measurement and they're on congruent circles, we can say that yes, these arcs are congruent to each other because they have the same measure and they're on congruent circles. Now for B, we were looking at AB and CD. Both arc AB and arc CD have the exact same central angle, and that is this angle right here. The measure of that angle is 80 degrees, so the measure of arc AB is 80 degrees, and the measure of arc CD is also 80 degrees. So again, this is 1/2 of the requirements that I need for congruent arcs. Both arcs have a measure of 80 degrees. The second criterion is they need to be on the same circle or congruent circles. And as we see, the circle that arc AB is on has a radius that is from the center to that point 8 right there. As far as the arc that CD is on, its radius goes from the center to point D. The red segment is longer than the green segment, so the radius for the arc CD circle is bigger than the radius for the arc AB circle. Therefore, these circles are not congruent to each other, so the answer is going to be no. So even though these 2 arcs have the exact same measure, they're not on congruent circles, therefore they're not congruent to each other. All right, that's it for this lesson. Go ahead and try the You Try Now problems, and if you have any questions, make sure you write them down and ask them next time you see you. Have a good day.